Okay, first of all, it's important to realise which angle it is you're being asked to find here. So we want the angle between TB, well that's here, and the base ABCD, so that's this rectangular base. Now what you normally do to find the angle between a sloping line and the horizontal is you draw a perpendicular down, which goes vertically downwards from the top corner down to the base, and that's this here, TM, which means the angle then that we want to find, if I draw in this triangle here, the angle that we need to find is this one here. Okay, so let's call that angle X. And what I need to realize is that in this triangle here, our angle TMB is a right angle because TM is vertical and MB is horizontal. So we've got a right angle triangle here. So we know some information about the right angle triangle. We know that this side is 6 centimeters. And if we're going to use trigonometry in this right angle triangle, we need to know the length of two sides in the triangle. Now we could either find the length of MB or we could find the length of BT. Now at first glance it looks as though TB might be the one to find, but in fact if we're going to use Pythagoras in this rectangle, then it's a bit tricky because although we know that this is 10, we don't know this length. So what I'm going to do is I'm going to use Pythagoras' theorem to find MB. Now it helps here if you think of this rectangle on the bottom, if we think of it as drawn from above. So I'm just going to draw that bottom rectangle from above. So it's going to look more like this. So there's my bottom rectangle. If I label it, okay, there's A, there's B, there's C, and there's D. We know that this is 7 centimeters. We know that this is 10 centimeters. And we know that M is the midpoint, which is here. So we are trying to find the length that goes from M to B. So if we can find MB, that's this length here, then we can find this angle X. So to find MB, what I've realized is if this is 7 centimeters from here to here, then actually it's only 3.5 centimeters from A to M. So I can use Pythagoras directly in this right angle triangle to find the hypotenuse. Let's call it Y. So by Pythagoras, the hypotenuse squared, Y squared, is equal to 3.5 squared plus 10 squared. Now that comes out as 112.25, which means that that distance from M to B is the square root of 112.25, and that comes out as 10.594, etc. Keep that in your calculation memory, or at least keep it on your screen. Okay, so this length here then is 10.59. Make sure you keep that exact. Okay, so if we now look at this triangle here, so we've got a right angle triangle. If I just draw the right angle triangle, this orange right angle triangle drawn from the side. Okay, so we've actually got a right angle triangle that looks like this. Okay, there is the right angle. That's 6, that's 10.59, etc. And we want to find this angle here, which is X. Right, labeling the sides of this triangle, the hypotenuse is this one, the opposite is here, and the adjacent is here. So we've got the opposite and the adjacent, and not the hypotenuse. Now, if we think of our right angle triangle formulae, we've got SO, and then KA, and then TOA. The one that uses the opposite and the adjacent is this one. So we're going to be using tan to find angle X. Okay, so if we just write it here, so we can see that tan of angle X is equal to the opposite divided by the adjacent. Now in this case, the opposite is 6. The adjacent is the 10.59 that I've saved in my memory. So to find, that's tan X. If we now want to find X, we're going to have to do tan to the minus 1. So use your calculator keys, work out 6 over 10.59, and then press Shift Tan. That comes out as 29.523 degrees. And to round that, they're asking us to round it to 1 decimal place. That comes out as 29.5 degrees. So the angle between TB and the base is 29.5 degrees.